Alright, this video is going to answer the essential question, how do I design a parabola for a solar hot dog cooker and then find the focus? How do I design a parabola for a solar hot dog cooker and then find the focus? The reason that this essential question is in your flipbook is because we're going to be doing this semester. We're going to be using what we learned about the properties of parabolas to actually design a solar hot dog cooker. You'll be graded on how well it works. So let's show you how you're going to create a parabola for the cooker. The first thing you're going to have to decide in your project is how wide and tall you want your parabola to be. So in this case, let's just say for our example, we want the parabola to be 24 centimeters wide and 10 centimeters high. You'll have an opportunity to pick your width and height when you build your own cooker. Alright, I'm going to go through the process of how to actually design the parabola and determine where the focus is going to be. So let's take a look at our graph. You're going to need to build a graph that is 24 centimeters wide and 10 centimeters high. And let's just assume that the unit of measure on this particular grid is 1 unit is 1 centimeter. So your first step is you're going to have to divide this up and put an x-axis and a y-axis here. So the first thing I'm going to do is let's go ahead and make our y-axis the bottom of the grid. So you can go ahead and use a straight edge, please. Get your ruler out, use something in your house that has a straight edge, the side of a book even, and draw that line across the bottom of your grid as a straight line. I'm trying to actually make it a straight line myself. It's not working very well. Alright, good enough. So there's our straight line, and now you're going to have to come up with a y-axis. So for the y-axis, you want to make sure, if you think about this, if the width is 24 centimeters total, then you're going to want to have half of that on one side of the y-axis and half of that on the other. So the way you do that is, let's just divide 24 by 2, and you're going to come up with 12 centimeters. That means you want 12 centimeters or 12 units to the left and 12 units to the right. Now if I look at this, I'm going to count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That gets me 12 units on this side. And I believe I can go one more on this graph because I put some extra units in here. So let's go ahead and draw our y-axis right here. Okay, now we've created our x-axis and our y-axis. Let's go ahead and label some points we know. The first thing you want to realize is when you build your parabolic cooker, the easiest way to build a parabola is to use the vertex at 0, 0. So we're going to put our vertex right here, and let's label that as our vertex. And I'm going to go ahead and write the coordinates 0, 0. This makes it much easier to find the equation of your parabola. And then if think about this, if the width of the parabola is 24 centimeters, we're going to go 12 centimeters to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 centimeters. Let me just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is going to be negative 12 on our x-axis. This is going to be positive 12 on our y-axis. So that's how wide our parabola is going to be. 12 plus 12 is 24 centimeters. Now for our height, let's go ahead and count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how high or how tall our parabola is going to be. I'm going to go ahead and mark that as 10. And that means we know that this point right here at 12, 10, this is going to be the edge of our parabola right here. We're going to call that, let's call that an end point. because that's where our parabola is going to end, and that's going to be at 12, 10. We know that's going to be on our parabola. We also know the vertex is going to be on our parabola, and we also know that negative 12, 10 right here, this is also going to be on our parabola. Let's label that another endpoint. And that's going to be at negative 12, 10. All right. So we know our parabola is going to look something like this, but we don't know exactly what the shape is going to be. And we don't know what the focus is going to be yet. We're going to calculate that. All right. Let's continue on. And if we want, you know what, let's put a couple markers here. I'm going to do this. You guys see this on your page. Let's put a little line right here. And put a little line right here. And let's put a straight line in between those two. Okay, oops, not quite straight. Let's try to move it up a little bit. There we go. And let's mark that a little bit more. I'm going to erase the middle part right here. And let's just make a note. This is 24 centimeters. Then let's go ahead and mark right here. I'll mark this part right here, and I'll mark down here. Let's put a straight line between those two, just so we see why did we mark the graph the way we did, because this is showing us that this is what our dimensions of our parabola are, which exactly match what we asked for in the first place. So this is going to be 10 centimeters. All right, there we go. 24 centimeters wide by 10 centimeters high. All right, let's go down to the bottom now, because now the bottom is going to help us step through the process of finding the shape of the parabola and the focus. We need to know the focus because that's where our skewer is going to go. That's where all the sunlight is going to be concentrated on, and that's where we want our hot dog skewer to be located. So find the equation of the parabola. Well, we know that when we're going to find an equation of a parabola, we're always going to find the vertex form. A equals x minus h squared plus k. Well, we know from our graph that the vertex, we purposely put the vertex at 0, 0. And that means our h value is 0 and our k value is 0. We already know h and k. All we have to do now is find what a is. And if you remember this from last semester, all we need to know to find the equation of a parabola is the vertex and a known point. So we have to know a point on the parabola. This is why we went and we figured out what the endpoint is, because I know that this point 12, 10 is on the parabola. Now I know negative 12, 10 is also on the parabola, but I'd prefer not to use negative numbers if I don't have to. So I'm going to use 12, 10. That's our other known point on the parabola besides the vertex. So 12, 10. And now we know from this that our x value is going to be 12 and our y value is going to be 10. So we know hk, x, and y. Now we can solve for a. Let's plug in those values. Y is 10 equals a. X is 12 minus h, which is 0 squared, plus k, which is 0. We can simplify this. 10 equals a times 12 squared. Go ahead and do 12 squared in your calculator. So 12 squared is 144. So 10 equals 144 times a. I just put the constant or the coefficient in the front now. And now remember, our last step is we got to get a by itself. We're going to divide both sides by 144. And a is going to be approximately 10 divided by 144. 10 divided by 144. And that's 0.069444. Now, for the sake of accuracy for our parabola, we're going to round this to 3 decimal places. So 0.069444. The 4 does not round the 9 up, it's lower than 5. So this is 0.069. It's approximately 0.069 is our A value. Actually, you know what? Let's put one more. Nah, I think we're good enough with the 0.069. Let's leave it at that. So our final equation here, now that we found A, let's go ahead and plug our value of A into our parabola equation. Y equals A, which is 0.069. Then we've got x minus 0. Actually, since we have x, let's just write this. X minus 0 squared plus 0. Well, those zeros don't do anything, class. We can go ahead and just rewrite this. Let me move this up. Let's rewrite this and simplify it a little bit more. Y equals 0.069 x squared. There is our equation for our parabola. That's going to be 24 centimeters wide and 10 centimeters tall. Alright, so we've got our equation. That's step number 2. Find the equation of the parabola. Alright, step number 3. Make an XY table of the points on the parabola using positive x values and plot these points on the graph. The last x value should be the end point of your parabola. Alright, let's start at the vertex. We're going to start at x equals 0. And looks like we only have to do 12 numbers here. We're going to get to 12. That's going to be the last number we need to graph. It looks like our table can fit all of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's all we need. We got to make sure we for sure graph that last point. And now what you're going to do, class, is you're going to take every one of these numbers and plug it into the equation that you found for the parabola, and you're going to get your y value. I'll do 2 of those for you. I know that when x is 0, y is going to be 0. I already know that because that's what our vertex is. So let's plug in the value of 1. So I'll put my equation in here, and I'm going to put in, our equation is 0.069, whoops, 0.069 times our x value in parentheses squared. Press equal, and we've got 0.069. Now when you graph things, you can just round it to 1 decimal place. You can't really graph any more accurately than that. So 0.069 is going to round up to 0.1. So we've got 0.1. Let's plug in 2. So we've got 0.069 times 2 squared equals, and we've got 0.276. That comes out to 0.3. So 0.3. Now, you can practice some of these. I'm going to write the rest of the values here because I've already done this for you. But I want to just show you. Just got to go through the process of finding every one of these values, and then we're going to graph these in a moment. So at 9, we're at 5.6. At 10, we're at 6.9. At 11, we're at 8.4. And at 12, we're at 10, which makes sense because at 12, we should be at our end point. And our end point was at 12.10. Now, if you when you're rounding, you might end up getting 9.98 or 10.01. Just round it to 1 decimal place. So in this case, it's going to be 10.0. Okay, that's our step number 3, make an XY table. Okay, and then it says, make an XY table of these points using positive x values and plot the points on the graph. Alright, so now what we're going to do is we're going to go through that table and we're going to go ahead and plot all of these points. So I'm not looking at the table, but I have it in front of me. At 1, at x equal 1, we're just above the x-axis at 0.1. At 2, we're at 0.3. At 3, we're at 0.6. Be as accurate as you can. At 4, we're at 1.1. 5, we're at 1.7. 6, we're at 2.5. 7, we're at 3.4. 8, we're at 4.4. 9, we're at 5.6. 6, we're at 10, we're at 6.9. That's not quite high enough. Almost right to the 7 mark, or 6.9. At 11, we're at 8.4. And at 12, we're at 10. Now at this point, now that you've graphed these, the next step is to reflect these points on the left side of the axis of symmetry. We know our axis of symmetry is the y-axis. So now what you're going to do is you're going to reflect these points on the other side. So now where you had 0.1 at 1, x value of 1, now you're going to put 0.1 where x value equals -1. And the next one we're going to go is 3. Try to be as accurate as you can on this. You get an accurate parabola. It's going to be at about 6, probably a little bit high. I think I made this point a little bit too high. I'm going to fix that right now. You want to make sure when your parabola is done, it is a really close estimate of the parabola, because the better you draw your parabola, the better your solar cooker is going to work. This is at 1.1, 1.7, 2.5, 3.4. I don't know why I'm getting that weird circle coming up. 3.4, 4.4, 5.6. Let's make sure I'm on the right place. 5.6 looks good. 6.9, 8, 7, 8.4, and then at 10. Alright, now I'm not going to do this on my paper, but the next thing you should do is, as accurate as you can, I want you to sketch your parabola all the way along these points. Sketch them all, connect them all together. I believe that's what the next step is. Step 5, carefully sketch the parabola. And then the last step is find the focus and plot it on the graph. We've learned already that the focus is found if we find the p-value. We need the p-value. That will tell us how high the focus is. And the way we find the value of p is, it's found with the equation 1 over 4a, which is 1 over 4 times, and our a value is 0.069. Now when you put this in your calculator, make sure you do the denominator separate from the numerator. So we'll just do 1, and let's put in 4. Move this over so you can see this. 4 times 0.069. So our denominator is going to be 0.276. 0.276, and now we can divide this in our calculator. So our final p-value is going to be 1 divided by 0.276, which is equal to 3.62, so approximately 3.6. So approximately, let's write approximately there. Approximately 3.6. So if that's our p-value, then let's find our focus. Our focus is going to be approximately 3.6 units above the vertex. So 1, 2, 3, there's 3.5. It's going to be about right here. Again, very important that you do that accurately. So there is our focus. Let's label that as focus. And I'm going to write it's 0, that's our x value, and then 0 point, sorry, not 0 point, it's 3.6. There is our focus. That's where your skewer is going to go for where your hot dog is going to be mounted for the parabolic cooker. Alright, so Last step it shows here is to draw a horizontal line connecting the two ends of the parabola. The reason that is because you're going to end up cutting this out, and you're going to need to have a straight line to do that. So I'm going to go ahead and draw a straight line across from this end point to this end point. And if you've sketched your parabola out, you'll have a perfect lines where we can cut that out and use that for our parabolic cooker. So there are the steps to designing your own parabola and determining where the focus is, so you can draw an effective and efficient solar cooker that uses the shape of a parabola to direct the sunlight right to where this focus is. And if that's where your hot dog is mounted to, then all the heat's going to go right to there, and we should get a pretty good cooker if we have some sunlight that day.